Radhavalabh Evans, this is the classes of the 10th class and it is also important for the 9th classes. I have today taken the exercise of 2.2 and in this classes we will discuss the details with and I will also explain the some trick. So I have brought the detailed solutions for you. So if you are new on my channel, please subscribe and comment and share this video to all the friends. Let's start how to solve these equations. Here the first question telling right now find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient number. Okay, there is the quadratic equations and quadratic polynomial because its highest degree of this polynomial is 2. Here also in equation 2 highest degree is 2. So these equations are or polynomials are called the quadratic polynomials. So there are basically 6 equations. So I have provided the detailed solution for you. So see that's how can solve. First of all, we need to find the zeros of this quadratic polynomial. If you don't know how to find the zeros of the quadratic polynomials, I have uploaded already in my channel. So go and watch there. Okay. So in the first questions, if you want to get the zeros, so first of all, try to multiply the first and last term. Okay. It will be coming the minus 8. You can write the minus 8x square and get the possible factors according to the demand minus 2x. So it will be the practical 4 and 2. Okay. So here you will take the minus 4 and plus 2. Then it is coming the minus 2. Okay. So according to these factors you can set and take the basic commons here the x. Okay. And finally you can write the x minus 4 into x plus 2. So the value of this polynomial is 0. After that you can set the 0 and now x minus 4 equals 0, that is the x equal 4. Here the second 0 is 4. Okay, x plus 2 equals 0. Finally we have the x equal minus 2. So zeros of this polynomial is 4 comma minus 2. Let's verify these zeros are right or wrong. Okay, so they are the basic formula for the quadratic polynomials. Sum of the zeros, that means the alpha plus beta equals to minus b by a. So if you add two zeros, 4 minus 2, here 4 plus and in brackets minus 2, it is coming the plus 2. So equals to minus b by a, that is minus 2 by a. You can check here, the middle term it is called the sum. So minus 2, okay. So I have got this. So this is the valid point, okay. And you get the product like alpha dot beta equals to c by a equals to 4 into minus 2, that is minus 8. You can check here. Here last term is the minus 8. So on this basis you can solve the other questions. Okay. Here last term you can remember this is the product side and this is the sum side. So you can take the second questions on this basis. So I got the zeros. Okay. Final like the s equal 1 by 2 and 1 by 2. First of all you try to factorize these polynomials and get the two possible zeros. Okay. So I have got 1 by 2, 1 by 2 and let's verify on the given formula alpha plus beta equals to minus b by a. So 1 by 2 plus 1 by 2 it is coming the 2 by 2. So equals to 1. So minus 1 by 1. Why? Because minus b here. Okay. That is the coefficient of in the minus side. So it will be the minus. So minus 1 by 1 is your the negative. So you can see here. So this is the like your middle term here the minus 4. If you try to get here the a and b. So what is the formula? Sum of zeros alpha plus beta equals to minus b by a. So here try to put what is the value of b? Minus 4 by what is the value of a? So 4. Here it is coming the minus 1. So I got okay minus 1 in this case. You can see here minus 1 by 1 because a is 1 is the showing the coefficient of a and minus 1 is showing the coefficient of b. Okay. So this is the valid answer. So on this basis you can also say 1 by 4 is the coefficient of your the like the product of this the polynomials. Here 1 and this is the here the c and this is the 1 because product of the this polynomial will be the c by a. So you can mostly put c ka value 1 and value of a equals to 4. So 1 by 4 is your the final answer. So that is why I got the 1 by 4 and I have taken the 1 because 1 is indicates here value of a equal 1 in each cases that is equals. Okay. So I can set proof. Similarly you can solve question number 3 on this basis. You can see here try to first of all arrange in the quadratic manner. So I got it and factorize 9x plus 2x plus minus 3 and then take the commons. and finally you got 2x minus 3 into 3x plus 1. And after that, write this statement, and this will be the valid for the purpose of the exams. And we have get the value of x equals to 3 by 2 and other the minus 1 by 3. There are two basics value or zeros of this polynomial. Let's verify for these two values it is the valid or not. So I got like minus 7 by 6 and 1 is the minus 1 by 2. If you verified on the given previous the statement, you will satisfied clearly. If you don't satisfied, comment me. We'll take the particular question. So this is questions number third, and you try to solve the 4 and 5 on this basis. Okay. Here the question number 4. 4u square plus 8u. This is the quadratic because this polynomial has not the three terms, but we can take the common of 4u over here. Okay. 4u into u plus 2. The value of 4u square plus 8 is the 0. So 4u into u plus 2 equals to 0. So finally we can say 4u equals to 0, u equals 0. And u plus 2 equals 0. That means the equal minus 2. So hence we got the two possible zeros of u equals to 0 minus 2. Let's verify it is a valid or not. So alpha plus beta equals minus b by a. So you can put 0 plus minus 2. That is coming minus 2 equals to minus b by a. Minus minus will be the cancels over here. Because here the minus 2 is the negative signs, but I wrote here the plus, so here it will be the mistake. You can take the plus signs over here. Okay, then it will be the fine. And on this for the product alpha dot beta equals to c by a, it will be coming this is 0 by 1, that is the value, and it is the proof. Okay, t square minus 15, you can make the complete square. So take square minus root in the 15 ka whole square. Okay. So using the identity j square minus b square equals to dash, you can get this the product. Okay, and factorize again, and finally got the two possible zeros for this t equal root under 15 and t equal minus root under 15. I have verified, got it the two zeros. After that, mention the verifications over here. You can see that, and mention lastly the verified. Okay, this is the way to solve this question. And at the end of this, the question number 6. We have the equation like 3x square minus x minus 4. So on this basis, you can also check that. And you got it, x plus 1 equals 0, x minus 1 equals 0. Okay, 3x minus 4 equals 0. So 3x equals 4. So x equals 4 by 3. So we have provided the sufficient information in the PDF files. Okay, you pause and see there clearly. And if you feelings the incorrect and not getting the clearly, you will comment. I will try to again resolve that's the problem. Okay, this is the solutions of question number 4 that contains the 4 questions, and I have the question number 2 that also talking about the find the quadratic polynomial over here. There are given the two zeros like the sum of zeros and the sum of zeros and the product of the zeros. There are given like two zeros. Okay, in this questions there are the also 6 questions. So how can solve? You can see this is the structure of or manner of the solution for this question. Let the quadratic polynomial be ax square plus bx plus c, and its 0 be alpha and beta. Okay, you can write in each and every questions for this. Okay, so you can write, so a plus alpha plus beta equal minus b by a equals to 1 by 4. Here you can see that by 1 and by 4. Here the value of a is not equal in cases, so we can take the value of 1 for the each cases, because one thing is remember in the quadratic polynomial a is the only unique value. Here want to get the unique value, so we provide the unique value, not differently over here. Okay, so we try to take the equals value in each cases. So we can mention the a equal 1 and b equal minus 1 by 4. If you try to take the a equal 4 and in the coming product like a equal 1, so it is the invalid. Okay, it is not good for the quadratic polynomial, because how can put? Because a is the only demanded the 1 times, not the twice times. Okay, so after getting that c equal 1 and c equal minus 1, you can compare this thing and you put final x square plus bx plus c, and you will get the final 4x square minus x minus 1. This is the final quadratics. Okay, polynomials. Again, you can solve the question number 2 on this basis. Here the PDFs, you can see that here the zeros root 2 and 1 by 3. One thing remember, if any of the question asking the sum of the zeros and the product of the zeros are given like, so you consider the firstly root 2 is the sum of zeros, and after that 1 by 3 is the product zeros of product of the zeros. Okay, so you can put the the formulas, and you will also comparing and get the values of ABC. Okay, and put finally in this the processing style, and finally you will get this the way. Okay, this is the final answer. And on this basis, you can also solve the question number third. Here the zeros product, sum and product are given zeros and root 5. So basically minus b by a equals to 0 by 1. Here a equal 1 and b equal minus 0. So it will be, doesn't matter because 0 doesn't contains plus or minus any sign. So c equals root under 5 equal 1. In each cases, value of a is the equals. So you can put 1 dot x square plus 0 dot x plus root under 5. That is the x square plus root under 5. This is our the final answer. Okay, so this is the way to solve. So the problems. Question number 4. How can you solve? Look at here. Here the 1 and 1. This is the very important. You will be asked in the examinations. This is the product and sum of the zeros are given over here. So you can put on this basis and compare, and we'll get the final A, B, and C value of A, B, and C. Okay, that's one. Here the formula like x square plus bx plus c. On this basis, you put 1 dot x square, value of b minus 1, and value of c plus 1. After that, you will get the x square minus x plus 1 over here. This is the wrong process. Okay, in the question number 5, they have made the mistakes in the calculation. So you can look over here. Alpha plus beta equal minus b by a, and sum of the zeros given minus 1 by 4. Okay, actually in this process, I have tried to add or get the sum by considering the both zeros, but these are the not zeros. These are the sum and product of the zeros. Okay, so that is why I made mistake. So but here I made the clearly. Oh, you can see there, and make your clear concepts. And I got the final value of ABC. Okay, and put finally and got for x square plus x plus 1. This is our the final quadratic equation. So, dear guys, this is the way to solve the such problems. But we have the also basics and some advanced and tricky solutions for the question number 2. So, this is the way you can directly put in the competitive examination or multiple questions asking. So, this is the way to use or clear this the problem. So, here the general formula of the quadratic polynomial x square minus sum of zeros into x plus product of the zeros. Okay, so here sum of zeros given 1 by 4 and product given minus 1. So take the first formulas. Okay, here the sum of zeros 1 and the sum of product, here the product of the zeros minus 1. So simply put and make the calculations away and get the 4x square minus x minus 1. You will thinking that we by here the 4 in the denom part, but for these things we will tag the 0 and cross multiplication and eliminate the zeros, and you write final the 4x square minus x minus 1. This is the final answer. So you can solve all this question on this basis. I have done clearly and getting the same answer. Okay, whatever that using the method in the previous processing styles, I will clear all these things. Okay, this is the way to solve by using the short tricks. Okay, for these things, one thing remember, on this basis you can solve any kinds of the quadratic equation if you have provided the 2 zeros, okay, over the other given quadratic polynomials. Okay, so this is the today's classes, and I will meet for the another classes with another questions. So till then, goodbye.